And also I will post the homework, number 3, and post the 2 papers that I give you, last week maybe. I'm not clear for the announcement, so I will make it clear. So Wednesday I will post the homework 3, and you will have will be given 1 week time to finish. And meanwhile, let me stop video and share my screen. Then we go to the cell type. So the cell type is the general is we have, let me talk about the cell we have, a little more so if 2 or more type of cells to make a tissue. 2 or more type of tissues to make an organ. Okay, so tissues generally we have more than 2 or more than 2 type of cells. For example, so we have epithelial cells, we have epithelial, and dermis layer. So tissue, skin is organ. So skin is organ, right? And we have in the dermis layers, we have fibroblast cells and the blood capillary related cells or nerve. So skin, dermis is the tissue. So here's a general introduction about the tissue and organ. 2 or more type of cells, 2 or more tissues to make the organ. So generally it's we also talk about, because the basic components is this one, the cell. So we know the cell membrane. You will see we already introduced before, have 2 type, like this. Let me give a little bit of detailed information here. So this area is hydrophobic, and this one is hydrophilic. Hydrophobic. So hydrophobic interaction. Why? The hydrophobic face inward, because outside is water environment, okay, or hydrophilic environment. So hydrophilic, and hydrophilic face to hydrophobic. So that's called make a system with minimized energy, very stable, and the inside is the nucleus. The nucleus. This one, and the mitochondria too is the energy factory, or energy make ATP. The place mitochondria, and let me a little more we have a lot of nanofibers. That's to make the cell have a specific shape, a movement. And the Golgi is related to kind of protein movement, and this one and this one lysosome specifically is pH less than 5 sometimes. You can put 5 or 6. So what this is one? So any materials where finally if foreign body materials, if engulfed by cells, we'll go to this one for digestion. And many cancer drugs or nanomedicine go to this way. We can design a bullet or magic bullet, go to the lysosome under the pH sensitive acidic, then open the chamber, later the cancer drug release. So lysosome is very useful right now. We apply lysosome's pH acidic for cancer drug delivery. So this one is primary cell type. We have a bilayer structure, like this one bilayer, and we have energy machine. We have gene, nuclear genetic materials making, and also with the lots of nanofibers, microtubule the filaments, microtubular cycloskeleton to make the cell have a shape migration. So that's the things. So look this one. We have in biological or clinical, we have histological views. Histological are very similar to mechanical. We have like to make different perspective. To make the plant out, and so that's one's like we have a tissue, make a different cut to get a section, and use a microscope to take a look at each section, the cell shape and the protein distribution. So we can use this with histological sections. That's to investigate effects of plan of the sectioning. And meanwhile, we said antibody with different color, we call the staining. So that's we had histological staining. That's that you will see in the if even all kind of like biological, specifically tissue engineering research, we need a histological staining to look at different position, different locations, the tissue, what it look like, and can we find a specific kind of cells, and what is the morphology of these cells or the ECM. So that's the histological section. So you will see like we have four type of 1, 2, 3, 4. Only this one can be spontaneous regeneration. Only the epithelial layer. So epithelium generates like in the top of the tissue of the surface. Connective tissue, muscle, nerve, they cannot be spontaneously regenerated, like skin kind of things. Okay, so only like this one have this function. So we will one by one to introduce you guys for the tissue classification. So connective tissue generates like ECM in extracellular matrix, and that's a continuous, and some tissues also with cell continuous. So it's like a continuous ECM, and epithelial is a cell continuous. For muscle, it's the muscle nerve cells surrounded by a basal lamina. This lamina is collagen when we talk about, and the basal epithelial cells are attached to a basal membrane. So that's the kind of introduction. A little bit details next go to. So generally between epithelial and connective tissue, so there is a base membrane generates. Any question? Yeah.
Can you please let Taylor in?
Pardon?
Can you let Taylor in?
Which Taylor?
Taylor Opperman.
Sorry. Yeah. Got it. Thank you. Let me know. this one. So here's like, we have base membrane. So the base membrane generates separate connective tissue from epithelial tissue. So that's it's between, that's the epi, that's the connective tissue. Yeah. So that inside there is a nano membrane, separated epithelial and connective tissue. So this one is a continuous sheet with like around 50 to 300 nanometer thick, and no cells contained with the BM. It is a non-living structure. It's and the principles like this one, type of collagen and the laminin, these two, we always use this one. That's like we will like mimic the laminin structure. And that's interesting. So if you can design or like a little bit similar structure with laminin, and a lot of cells will be happy to live with that. So we use this one, laminin structure, to regenerate tissue, skin, nerve, everything. So laminin is very useful. That's the principal constituents, compounds. So look at this one, it's a muscle. So muscle, that's the muscle plasma membrane. So it means like plasma membrane means like it's a bilayer structure. This one, they generally have some kind of striated structure, or like they are aligned together. We will give a little bit of details in next several slides. The cells inverted or live in a connective tissue. And also, they have some, basal lamina film to separate the connective tissue with them. And epithelial is, as I already said, epithelial is generates, is like on the surface layer, and the lumen structure, in the lumen or capillary or tube. We will talk about a little more details because this part is a little bit basic. So epithelials, you only need to know the epithelials in the top of the surface, and we have a different type of epithelial. So also like this one with a connective tissue, between connective tissue and the epithelial layer, we have what? A base membrane or basal lamina. Even for kidney glomerulus, so it's the blood, like this one is the blood here. And you will see, some epithelial cells and endothelial cells, epithelial cells. Between these two, we have a base membrane, and this part is like in the urine system. And if we use already introduced before, TM specifically focused in the nanostructure. We can look like a few nanometers, to definitely like we use like 200 nanometers. Okay, so specifically for like 10 to 20, 30 nanometers. Otherwise, like we can larger than one, we definitely can create clear pictures using SEM. So so what is nano? Nanoparticle, for examples. Nanoparticle generates like should be less than 200 nanometers. Okay, that's a definition. So if we see, okay, nanoparticles, we generally need less than 200 nanometers, because below this number and above this 200 nanometers, let's have a different effects on cell behavior. So here's like using TM, a high resolution, our department has a high resolution, means could go to the sub-nanometer levels. So they use like the facility is cryo TM and with liquid nitrogen to treat example. And the ones very expensive. And in Canada, very limited numbers in Canada. So the facility is expensive and use liquid nitrogen to freeze, to get the materials frozen. That means the atomic movement also, the movement can be done and to get high resolution image. So that's that. Talk about the TM. This one is a red kidney glomerulus, and the like this one. There is again. There's a film. Like this one. Let me check this one. Okay. We have this layer, that's the base membrane. So base membrane to separate two tissues. And like this one is a capillary, you can think about is like a blood vessel kind of lumen structure. And with like capillary endothelial cells on this surface. And however, go to that way, we have like some urinary space in this area and have some epithelial cells like this structure. We will talk about a little bit more. Even zoom in, we will take a look at in next several slides. And that's why SEM for the corneal, because SEM is like generally is like we use like larger than 100 meter size use SEM. That's the cornea of a chicken embryo. This one cells. Okay, that's what cells. That's what this is the membrane. That's the BL. That's the base membrane. Like this one. It's interesting, amazing, structure. Look at the human body. All tissues, they have a different type of function. And the tissue between tissue, they have a very clear separation. Base membrane, beautiful structure, right? A nanostructure, and can uniformly separate different type of functional tissues. And the cells, you see, they make a connection. Let's make a connection. And in the ECM structure, that's the ECM materials. And a lot of ECM materials. We will talk about collagen. That's the collagen ECM. That's also the collagen. And E is epithelial cell, right? That's it's really beautiful, structure. So here's like a more connective tissue, and we have like the tissue, connective tissue cells in a semi-solid. What kind of semi-solid? We can gel kind of structure with a bit thicker collagen and elastic fibers. So we have loose fibers, the packing tissue between organs, shares the muscles, nerves, and the blood vessel. So this kind of, it's a loose fibers. If we compare to the cartilage, we will talk about. The fibrous, fibroblast cell activity forming fibers, collagen fibers, and the elastic fiber. So we know the elastic. We talk about the elastin, right? So elastin is the elastic protein. So that's why a lot of tissue have some elastic property. And some even dense, if you like, loose, dense is like, some fibrosides, collagen fiber always there. Collagen fiber and the elastic fiber, that's the basic. Very strong and pliable, flexible, but not kind of super elastic, inelastic. Ligaments, capsule joints, heart valves is denser, a lot of denser fibers there. Elastic, that's blood vessel. So we need strong, extendable, flexible, elastic tissue. So basic compounds is elastic fiber, elastic materials, collagen. So elastin, collagen. So involves blood vessel and the air passage in the lung, right? Bronchial structures. That is like elastic connective tissue. If we take a look at, as we said in the beginning, HE staining, some histological staining. That's it. Histological staining. And we use a different chemical antibody for, make some, chemical conjugation or like physical adhesion. So later the different tissue have a different color. So you will see here's a connective tissue like this one. This one typically outside is epithelius, top of the surface. Then we have loose connective tissue. Like this one, the bread one, a lot of bread thick, that's the elastic fiber. Elastic fiber, like this one, this one, this one, this one, this one, right? That's the very dense elastic fiber. That's loose, you will see. The elastic fiber and collagen fibers is very loosely distributed. And however, for epithelial, because a lot of epithelial cells, epithelial tissue, and they are on top to provide protection. So always, generally, epithelial tissues always very densely packed. Yeah. So we will go to the next one, the loose and loose connective tissue. You will see a lot of fibers. Fibers like this one. We have collagen fibers. We have elastic fibers. We have some other things. Make a network. We have blood vessel in connective tissue. So you will see if get cut, if get injured in loose connective tissue will form a scar tissue like this one, and a lot of immuno-related cells like macrophages, mast cells, and lymphocytes, macrophage, and some basically is fibroblast cell. That's the basic or primary cells in connective tissue, and all form amorphous matrix, right? And besides this one generates loose connective tissue, we have this one fatty cells. You see a lot of the fatty yellow is a fatty tissue, right? Fat tissues, and the nucleus here a little bit, nucleus here. That's why it's adipose cells, adipose tissue, and so that's the. If we take a look at the dense it means like the muscle, cardio, muscle, cardiac muscle, skeletal muscle. That's a dense connective tissue. Like this one, that's a tendon kind of structure. A lot of like you see like tendon. A lot of nanofiber collagen fibers. They align the growth, compact together. Then like this one is a blood vessel. You will see blood vessel go inside. It's a bit different. So tendon, a lot of aligned fiber make a packed together. That's later the tendon, very tough. And you see that's the cell, the nuclear fibrous nuclear. You see between this one. Okay, That's nuclear. The nuclear genetic material is there. And that's the longitudinal bundle of collagen and elastic fibers. So let's their structure really, really strong and tough. If we take a look at like the longitudinal section of tendons, shows like that's the histological staining. We see the cell nucleus, tendon shows some fascicles. That's like lot of abundant of collagen, aligned collagen fibers. They're bonded and the fibroblast. And here is the connective tissues like adipose tissue. Right now, this one is really, really hard to research for therapeutic application. They found that adipose or fat cell can do everything and no damage to other tissues. So here's like adipose tissue, like that's the fat filled cells, only a little bit small. That's for the nuclear. And that's the ECM, that's the supporting collagen fibers, ECM, extracellular matrix. So provide a protective cushion for organs and also for energy, kind of an insulating layer in the skin, storage of the fat reserve, like this one. That's a collagen, that's the H, histological staining. Like this one, majority part is a fat. Only a little bit is nuclear, nuclear. And that's why ECM, the collagen fiber. That's the histological stain. We can take a look at it, use a microscope. We know that different, generally it's like yellow, brown. So brown, we will talk about most if you're interested in the brown fat cell is right now is like kind of, they found the brown fat cell even more kind of active for a stem cell. So here's like a connective tissue bones. That's the cells in the solid rigid matrix that's impregnated with the calcium, magnesium salts to get staining pictures. You will see like the bone cells of generous osteoblast. So which look like what? A tree, right? With a ring structure. So that's the nature's like most amazing things. You can also find make a connection in all living biological systems or living systems with the other natural nature system. So that's like a lot of bone cells. They form with the ECM, the collagen and the hydroxyapatite structure, form a ramelar kind of structure with a ring kind of structure, right? And you will see inside, we will see the traversing canal with blood vessel go inside. And like this one, that's the blood vessel come out, and it's like traversing canal, and like this one is the bone cells, and so that's like different kind of, we says like lamellar structure. They self-assemble together, so form a rigid framework of the body. So here's like the bone tissues again. You will see like the traversing canals with blood vessel, and like this one, that's one's lamella, and between lamella is kind of, we call the interstitial lamella. That's like ECM, kind of for bone cells ECM. And outside, I want to say, we talked about it before, that's the epithelial layer. That's the epithelial layer. So in the epithelial, the bone tissue, the bone tissue also have some epithelial layer. That's like, we say it's like some hematopoietic. So that's one interesting layers, like it's kind of with strong regenerative capability of this tissue. Yeah, with a lot of stem cell there. Very interesting. That's we call sometimes the traditional name is a bone membrane. That's the epithelial tissue, and can be used a lot for bone regeneration. And we got a little bit more, connective tissue, cartilage. The cells, inside the elastic matrix with like fibers. That's like hyaline cartilage. So hyaline cartilage is like cartilage cell that's for the air passages and the bone joints, stage of bone, because for the younger people or the bone, baby bones, more kind of this cartilage structure. And the matrix, matrix and white fiber cartilage is very tough. This one is like firm but resilient. So that's like pretty good for in the long air passages. And this one is like invertebrate, is a tough structure. So white fibro cartilage, even amazing things like they are also from a ring kind of structure. Very interesting. Yeah. It's a tough layer by layer, make a kind of like a wrapped structure with cartilage cells, collagen fibers, and resistant to stretching as a shock absorber between the vertebrate. And this one, the third type is the elastic and yellow fiber cartilage. It's more flexible, resilient, in the ear. So this one is cartilage cells or fiber, elastic fiber in mattress also with collagen is always there. Look, this one is like a connective tissues with cartilage and cartilage like this one is a hyaline cartilage, like in the access bronchial structure, that's trachea, like this one. There are some like rockener structures, like a few cartilage cells or chondrocyte cells inside. And the elastic cartilage, so cartilage identification is like principally based on the rockener, right? Rockener structure. This one is a rockener. Little areas, and only a few chondrocyte cells still living there. ECM is a type 1 collagen for fibrocartilage, or hyaline is type 2 collagen with elastic or without elastin. That's the fibrocartilage. And a little bit most, like I feel a bit maybe you guys a bit challenging. So let me like do a movie first. It's around 9 minutes movie. Then we go back. Okay. Let me. Oh. This one. I think. Oh. Can you see my screen right now? Any students can confirm?
Yes.
Right now, still you can.
No.
No, right now. Right now should be okay. Yeah. Can you see the movie screen?
Yeah.
Okay, perfect.
Video, I'll discuss connective tissue, epithelial tissue, nervous tissue, and muscle tissue. So let's get started with connective tissue. Connective tissue is one of the 4 types of tissues found in our body. Connective tissue helps provide structure, support, defense, transport materials, and binds things together. Connective tissue is unique in that it consists of cell fibers. These fibers include collagen fibers, which are tough fibers, and elastic fibers. In addition, the cells are separated by a ground substance, which is made up of water, fluid, and a mix of proteins called matrix. There are several different types of connective tissues, and they're found throughout the body. First up are loose connective tissue. It is composed of collagen and elastic fibers. It is found in and around blood vessels and organs. Next, you have fibrous connective tissue. They have a large amount of collagen and few cells. They are found in tendons and ligaments. Cartilage is a connective tissue. It is found at the end of bones and in our nose and ears. Adipose connective tissue is body fat, and it is used for insulation and to help store energy. Blood is considered a special type of connective tissue, and the cells are separated by fluid. And bones are also considered a type of connective tissues. So as you can tell, connective tissues are important. They help attach bone to bone, muscle to bone, move materials around in the form of blood, give us structures in bones, and also help us store some fat tissues. Our body is made up of several different types of tissue. Our epithelial tissues line cavities and cover surfaces of vessels and organs. They provide several important functions. First is protection from such as sunlight and pathogens. Next, they're involved in secretion of sweat or hormones and even mucus. They also are involved in absorption and exchange. For example, oxygen and CO2 are exchanged through epithelial tissues, and also epithelial tissues are important in sensation and how we touch and feel our world. Epithelial tissues are divided into several different types and are classified by both their shape and the number. First up, you have squamous. Squamous are like pancakes. Their width is greater than their height. You will find these in the lungs and the blood vessels. Next up are cuboidal. Cuboidal tissues have a width and height which is the same like a cube. Many times you find these in important glands. Columnar tissues are just like a column. Their height is greater than their width. You find these in the digestive tract and possibly the trachea. They also are divided into simple, which are one layer, and stratified, which are multi-layered. Epithelial tissues, again, line our outside of our body, inside of our vessels, help keep us alive. Nerve tissues are found in your brain, spinal cord, and the peripheral systems. Many nerve tissues are made up of nerve cells, which are called neurons. Their job is to transmit electrical signals throughout the body. They allow your brain to communicate with your body. A neuron has several parts. First, they have a cell body. The cell body contains the nucleus and other organelles like the mitochondria and ribosomes. They also have structures called dendrites, and they look a bit like tree branches. These dendrites receive electrical signals from other neurons. Next, a neuron has an axon. And the nerve signal passes down the axon. An axon has insulation called a myelin sheath. At the end of the axon, you have an axon terminal that communicates with dendrites of other cells. This allows electrical signals to pass and flow throughout your body. There you have nerve tissues, a group of neurons working together to pass electrical signals from your brain to many parts muscle of tissue. Muscle tissue is one type of tissue found in the human body. Muscle tissues are responsible for movement inside and outside of the body. Check out these muscle tissues at work.
So that's the generous introduction. Give us short movie. Then hope like in the next lectures I can like give you details about like the epithelials, the heart tissue, and the bone tissue. More details. And I stop here to answer your questions if you have any question. You guys have any further question about about your homework and my project, anything? So no question? So no questions like let me take the chat. Yes, okay, good. And we stop here. I will stay in the classroom. I could answer your questions if you are in person want to ask me. Thank you guys.